Hello everyone, welcome to the VFX Showdown. Today we're here to talk about a new feature called Visual Effects Editor. This is a magical feature that allows you to create amazing visual effects straight from Effect House.
So we thought that we would get started by giving you a quick overview of what this feature is, even what VFX or visual effects is. So VFX is something that can mean a lot of different things depending on what tool and industry you're working with. For us at Effect House, we think of VFX as basically a system that will let you use particles and a lot of them on screen at once to make a lot of really dynamic things happen in your effects. You can see that really simply with some nodes that you set up in Effect House, you can make some really complicated stuff. So show a little bit more about in Effect House, you'll see when Rustin does the demo, this is a whole new graph that will use nodes only, no code required, to create complex effects with a lot of particles. And this feature basically uses the phone's GPU to simulate and render particles and put them in your effect so that creators around the world can use them. As part of this launch for this new feature, we're also adding a lot of new learning resources. So make sure to check out the Effect House website. If you go to effecthouse.tiktok.com/learn and then search for Visual Effects Editor, you'll see we have a bunch of articles, step-by-step tutorials, sample projects, and a lot of stuff like that to help you get started. So you're not alone, we're here to help. Even though we're launching this feature publicly today, we've actually already been doing a beta program with some of our creators for the past few weeks. And I wanted to showcase some of our favorite effects from the beta. So first, this creator, Amy, made this amazing effect using the Visual Effects Editor that is exactly how I feel when I'm trying to think about math, which is lost. And then the second effect is by a creator named Florencia, who made an effect where you are surrounded by a tornado of smoke and fog. And then when the tornado is gone, it reveals that your hair was blown off in the tornado, which I think is really funny. And finally, this final effect from this creator, Karma is my dog. She created a minigame effect, and you can see that it uses particles from Visual Effects Editor to be ketchup in this hamburger game that you're playing. So as you can see, it's a lot more than just fireworks and fire. You can do so much with particles, and you can do so much with Visual Effects Editor. So please let your creativity guide you and try something new that's never been done before in AR. You might be asking, why should I participate in visual effects? Why should I learn this new feature? Definitely, we recognize learning any new feature. There's a learning curve involved, and it takes some time. But we wanted to share that the reason that we built this feature is because effects with VFX and particles are really popular on TikTok. So if you're looking to build an audience or build an effect that will get used in a lot of different creative ways by creators, VFX is a great opportunity for that. Another reason is that a lot of brands love requesting effects that have VFX or particles. I think this is one of those things that really adds an extra level of polish or shine to an effect that you're working on. All right, and with that being said, I'm going to hand it over to Rustin.
Hey everybody, and welcome to the VFX Graph live demo. I'm going to be walking through creating a pretty simple fireworks effect, but this is going to be very customizable, and feel free to change anything you see me do along the way. Plug in your own values, make this your own. We're really excited to see what you can do with VFX Graph on your own. We'll add a new object, and we'll see down at the bottom here, we have our new visual effects category, and we'll just add a basic particles. So you can see the default VFX graph we've added here is just going to spawn a bunch of particles in the center of the screen and send them out in random directions. So with our fireworks effect, we're actually going to be making something like 4 VFX graphs in one. I feel like this is a very good first beginner effect, but it's also using one of our more advanced features, which is GPU events, which allows you to spawn particles from other particles. So we're going to use that to first create some colorful fireworks like mortar shells that are going to fire up from the bottom of the screen. And then when those particles die, they're going to emit an event, which is going to spawn more explosion particles from the spot where those original particles died. And then we're going to create 2 more graphs, which are also going to spawn trails behind each of those as they move. First thing I want to do here, I want to change the random velocity so that we're getting a lot of upwards motion instead of just flying out in every direction at random right here. So I'm going to lower the amount of randomness on the x-axis and on the z-axis as well. We'll bring it to -1 to +1. And then for the y-axis, I'm going to change it to something like 5 and 15. So we'll get some upward motion. Let's see what that looks like. We'll see that whenever we created this new VFX graph, we've got 4 blocks here. The first one is going to be our spawn block, and that's going to be responsible for actually creating these particles here. So we have a spawn rate that we can change. It's constant right now. And every time I change a variable, you're going to notice that these don't automatically update. I'm going to click this compile button so that we actually see the changes here. So now we have just 1 particle a second. I'm going to bump that up a little bit more. And then I'll just take you through what each of these actually means as well. So the first block in the init context right here is our capacity. That refers to the total capacity of these particles that we're going to be spawning. And this has a big impact on performance. So for the most part, I'm just going to leave this at the default of 2000 while we're doing this demo. But typically one of the first things you'd want to do once you have a first pass on your VFX graph is go through and make this capacity as low as you can get away with without cutting off particles that you want to spawn. So if I set it really low to something like 5, you're going to see that it's going to spawn 5, and then it's going to stop spawning, and then it's going to have to wait until the ones that have already been spawned die. So we just have 5, they've flown off the screen. They're going to die after a couple seconds, after 6 seconds, and then we get new ones. So bump it back up. That has a big impact on performance. Even if this many particles aren't alive, it still has to do a little bit of work of looping through this many just to see if those particles are alive, see if there's any work that needs to be done for them. Let me check the chat right here. Does the engineering team have any resources or advice on how we can learn the backend principles, performance on the GPU? So I think this is going to be really important for that. Pay attention to that capacity. Frank also mentioned briefly the idea of overdraw. So the larger these particles are on the screen, the more expensive they're going to be to render is also kind of a good rule of thumb. And also we can see in the output here, we also have a few different modes for blending these particles together. By default, it's additive. I believe additive is fairly cheap. Alpha is going to be more expensive. Alpha pre-multiply is going to be as expensive as alpha. And then opaque is going to be the cheapest. So if you can get away with making your particles opaque, that'll help your performance somewhat because the GPU is not going to have to render each of these pixels over and over and over. Oh yeah, and then I figured I would go with a really basic background video just so we have good contrast. We can see what we're doing. So to go back through the init here, the only other default blocks we have, I'll explain what init actually is. So once we've spawned the particles from this block, it's going to execute all of the what we call block nodes, which are these nodes inside the init block. So we have the capacity, which you've already seen. The init block runs once whenever the particle is spawned. So this is going to set a random velocity once at the start of the particle's lifetime. And then it's also going to set the lifetime of the particle in seconds, which means that after 6 seconds, these particles are going to die. And then we have the update, which is going to run every frame that the particles are alive. So if we want any logic in here, like gravity, motion, we can add that to the update context here. And then output is responsible for the visuals. So if we want to change the texture that shows up, if we want to change the blend mode, those options are going to be under output. Cool. So hopefully I taught myself, realized not everybody knows exactly what we're looking at here. Hopefully that explained everything. But of course, if you have any more questions, feel free to drop them in the chat. So I think this is starting to look like a decent base. What we want to do next, I want to try and replace the lifetime with a random lifetime that's a little bit shorter. I think the lifetime is a little bit long right now. So let's do a random lifetime, maybe between 2 and 3 seconds. And then I also want to spawn these down from below in the bottom of the screen. I'm going to go ahead and hide the TikTok UI here. But we have a node. I'm going to use the position box node, which is going to allow us to set a random position for the particles within a 3D box. Then I'm going to position that box down by a few units. More than that, it's probably going to have to be like -50. Let me zoom in a little bit more for you. Okay, that's a little bit too far. Let's try -20. That's about good. Maybe get them a little bit further just so they're coming out from the bottom of the screen. Turn down the scale on the Z. Actually, turn down the scale on the Y as well. So we really only are getting a lot of variation on the X axis. Let's see how it looks with 12. Give it a little bit more. Maybe 20. I think that's looking all right. Let's also change the size of the particles. So we'll give it maybe 0.2 on the x-axis, try 0.5 on the y. See how that looks. That's about what I'm looking for. We're also going to set some random colors. I'm going to give it a little bit more lifetime, or yeah, a little bit more lifetime. So the next thing we want to do is add, let me check the chat. Let's add a random color here. So we're also going to set a color. And then now I'm going to introduce a different type of node. So far, you've only seen the block nodes. We also have these operator nodes where we can, anytime you see a little port here, similar to visual scripting, we can connect a node to this port. And this is where you would do any of your math operations. It's really like an arbitrary amount. You can go as complex as you want with the operator nodes. I'm going to try and keep it simple just for this demo, but these are like where the power of the system really lies. So real quick, I guess I can just demonstrate what it'll look like if we set all the colors to something like 1.5.5. So this is in RGB. So X is R, Y is G, and Z is B. But one thing that I find really useful, we could also work in the HSV color space instead of the RGB color space. So if you're not familiar, what this means is instead of X being red, Y being green, and Z being blue, we're going to treat it as X being hue, and then Y being saturation, and Z being value. And value basically just means brightness. So what this is going to allow us to do is pick a random hue for each of our particles, but keep it at a consistent saturation and value. So we can bump up the saturation, give it a maximum brightness. And then what we can also do is just add a random node here. So we're going to select a random hue from 0 to 1, and I'm going to make this a vec3 node. So actually, we're going to copy this over and this, and let's see how this looks. Pretty good. So now we've got these mortar shells coming up with a random color. We're also going to add some gravity to them as well. Let me go ahead and see what we've got in the chat, if I can answer any of these questions here. So about different blend modes on materials, I believe we are not launching with material graph support, but on our roadmap, we want to support arbitrary materials from material graph in VFX graph. So I don't have a date for that, but look forward to that eventually. Let's see here. Is it possible for particles to start emitting before the effect begins? I don't believe that we currently have a feature like that. I think in other engines, they call that something like pre-warm. I don't think we have that currently, but definitely if that would be important for you or like deal breaker, vote for that on the forums. Let us know that that's an important use case for you. That's exactly what we're looking for right now, is feature requests like that. So great question. Thank you, Simon.
There was always also someone asking what the colorful nodes are. They're more than a comment box, but if you could explain maybe context nodes versus block nodes a tiny bit.
Yeah, totally. So we were saying at the beginning, we have these groupings of block nodes, and these basically just refer to where in the particle life cycle these block nodes that are inside the context nodes are taking effect. So spawn means this just controls how the particles are spawned. So I want to change it to 30. Now we're getting a lot more particles. And then init only is executed once at the very beginning of each particle's lifetime. Update, anything in here gets executed every frame. And I can demonstrate that right now as well. We want to go ahead and add some gravity to these particles. So we can see how that looks like. We're going to have to bump up the random initial velocity to allow these particles to counteract the gravity that I've added. That looks pretty good. Maybe a little bit slower so they're not shooting off the top of the screen. But yeah, hopefully that can illustrate what the difference is between these colorful context nodes. I've added this gravity block to the update node, so it's running every frame. But if I disable it and then I add gravity, we don't even have a gravity node enabled in the init context. But if I were to add a gravity node in the init context, it wouldn't drag them down like you saw in the previous, before I unchecked this, because it would only be running once. It doesn't run every frame. Hopefully that explains what these context nodes are. But like I said, we're also going to be making 3 more VFX graphs within this graph, and they're all going to have their own set of nodes like these. So hopefully that'll illustrate what they do. Can you explain the difference between capacity and set random lifetime in layman's terms? Yes. So capacity is just a cap on how many particles you can have at once. And it's upper limit for performance so that you can't accidentally spawn millions of particles and crash your phone. And we also have to know ahead of time what the maximum number of particles you want to be in your system is so that we can allocate enough memory on the phone for that number of particles. So like I said, if we set the capacity really low and you're trying to spawn more particles than you have the capacity for, it's going to stop spawning them once you run out of capacity. So the idea for capacity is set it as low as you can without breaking your effect, basically, because that's going to give you better performance. But apart from that, lifetime is like how long the particle has to live once it is spawned. So after this many seconds, the particle is going to die. Let's see, are the block nodes like an undocked inspector panel? I think the best way I would describe them is just anything you would do in visual scripting or material graph currently. That's kind of like you could do the same thing with the operator. Oh, you said block nodes, not operator nodes. My bad. Block nodes are more like specific functionality. And you can see if I click this add block, what all the block nodes look like. We've got quite a few of them. And they're mainly just for setting different attributes on the particles. The particles have a ton of different attributes like color, size, alpha, lifetime, position, velocity. And you basically use the block nodes just as an interface for setting those properties. And then if you want to do something more complicated that doesn't have built-in functionality, position box has a lot of built-in functionality. But if you wanted to, you could replace position box with a set position node. And then I could do a bunch of math over here using my operator nodes, and I could plug it into the set position, and I could get similar functionality to this position box node. So block nodes are basically like an interface for you to set attributes on the particles. Let's see, so we can't change the spawn through the effect. Let's see. I think we can if you expose this parameter. I'm not totally sure. Maybe somebody else could jump in because I believe this is a fairly new feature. But I think we can interface with, maybe if I hit expose, yes. So if I hit expose parameters right here, now we have a spawn rate that shows up whenever I click on basic particles in the inspector. And if I click this right here, we can set this from within, where is it? We can set this property from within visual scripting. So you can expose parameters to visual scripting and work with them. The chat is starting to move a little bit longer or a little bit quicker than I can keep up with. So I may have to just move on with the demo and then revisit the chat towards the end. So my apologies, but I will try and eventually, if we have time, get back to more of the questions. And then also you'll be hosting office hours going forward, and we'll definitely try and answer all the questions in a timely manner as we're able to. So feel free to keep asking questions. But I'll go ahead and show now that we have our colorful fireworks shells flying up and then dying. I'm going to show how we can spawn additional particles from these particles. Let me just size up my preview just a little bit more. And then perhaps this. So what we can do is we can add in our update block a trigger event on die. So what that's going to do is whenever these particles die, it's going to spawn a new particle in a new VFX graph that we're going to create right now. So we can pull out this GPU event, and it's only going to give us one option to create a new spawn GPU context. And then we're going to go ahead and drag out from the bottom an init context, an update context, and an output context until we have something that looks more or less like the one that we started with. We're also going to add a set main texture, leave it as default, and then we can see what that's going to look like. And what it's going to do is it's going to spawn a bunch of particles right here in the center of the screen. It's actually going to spawn 300 of them for every particle that dies. We don't want quite that many. Let's bring it down to something like 30. And then you might also be wondering, well, what good is this if it's just going to spawn them right in the middle of the screen? There's a lot of other really cool blocks that we can add to the init context here that are the inherit blocks. So we can start by seeing what will happen if we add this inherit source position and hit compile. So now the particles are going to spawn where the parent particle died. And so let's do a few more things to make these look how we want. We're going to make them much smaller. And then we're also going to give them a random velocity, and we're also going to have them inherit the color of the source particles. Let's see what that looks like. All right, let's make them quite a bit bigger. Let's make the velocity a little larger, maybe something like -3. We also want these to live quite a bit shorter. So let's set a random lifetime that's quite a bit shorter, maybe 1 second to 2 seconds. And let's also add some gravity to these as well. Let's see how this looks. All right, maybe I'll make the lifetime of the initial shells a little bit shorter. With that, we are almost halfway done. We are also going to add some trails for these mortars and then some trails for the explosions as well. And it should really make everything pop, really make this come to life. I also want to add a little bit of a set alpha over lifetime so that these don't disappear so abruptly. Maybe if these fade out nicely.
Real quick, can you
Yeah.
show them the component and asset? Can you describe that a little bit?
The component and asset?
Visual effects component and asset.
Oh, totally. So if I click over here in the hierarchy, we can see the object that I created whenever we went through and we added this visual effects object right here. And if we look in the inspector, we can see the camera that this VFX system is using to render. And we can also see the asset that is driving this visual effect component. And if we click on that asset, we can also see over in the inspector the properties that you have exposed to visual scripting. So if you add a parameter, for instance, we could do something like add a color parameter that we then have access to here. Let me accidentally. And if do we have to convert it to a vector 4 or a vector 3 maybe? Let's split it and then convert it into a vector 3, discarding the alpha here because the alpha is a separate property. We'll go ahead and compile that. And now we have a color, which is 0. So maybe if I set this to another color, we'll see. Didn't that save? Here we go. Yeah, there we go. You could imagine animating these properties within visual scripting. Anything you want to expose as a parameter can be exposed in the inspector here on this asset that you can then interface with through visual scripting. So let me quickly see in the chat. I can answer quickly. And capacity be changed dynamically? Not currently. I think that would be a pretty difficult engineering problem. So if that would be a deal breaker for you, let us know. But particles have different shapes. Oh, I see Frank is taking care of questions in the chat for me. So maybe I'll just get back to the demo. Let's see. Cool. So here we are. Let's increase the velocity a little bit more. And then I'll take you through creating the trails for our shells. And then we'll create some trails for the explosion as well. Minimize this so I have easy access to my compile button so that I don't have to move this every time. Cool. So what we want to try and do now, I've showed you the trigger event on die block. We're going to use a different block now where we can trigger events at a given rate. So we can either have them happen over time or over distance. Let's give myself a little bit more room to work here. We're going to move this over here. And then maybe you can also quickly demonstrate. We have the same comment functionality as in our other graph systems you may be familiar with. So super helpful for organizing things. You can also drag things around as a group with the comment handles. So I'll just use that to make things a little bit more organized. And then with our trigger event rate, bump this rate up to something like 50 per second. And then let's do the same thing we did for the last one. Let's drag out a new graph, starting with spawn GPU, going to init, going to update, and going to output. We're going to add another set main texture, and then we're going to, once again, inherit position, source position that is. We're going to set a random velocity as well. This time we're going to try and make it negative in the y-axis to try and make it look kind of like a rocket that's moving the firework up through the air. Let's set a small size as well. And let's also add an alpha over lifetime here. See how that's looking. Oh, not too bad. A very long lifetime, so let's set a random lifetime that's much shorter. Maybe something like 0.25 to 0.75. Pretty good. Cool. I'm feeling like these are a little bit too big compared to the explosion particles. So we're going to make the explosion particles a little bit bigger and give them a little bit more velocity. One more time. Let's try something like 888. And then last thing, we're going to add some trails to these explosion particles as well. And we can do the same thing as we did over here. We can actually, I can demonstrate, we can go ahead and copy all of these, save us some work. And then with an update, let's get another event rate, and we'll set it to something similar. We will pull this in here. We will get rid of this. Oh, my mouse is stuck. Here we go. Get rid of this random velocity, and let's see how that looks. There we go. Maybe bring the lifetime down a little bit more.
If you ever
Yeah,
have
there
any
you have it.
questions about a node too, Rustin, can you show the node info?
Absolutely. Yes. So we really want to emphasize discoverability for these nodes. So we try to make it as easy as possible for you to, for example, go in here, add block, just go through and search all of these nodes. Whenever you mouse over them, you'll get a description of exactly what it is they do, what their inputs and outputs are. Some of them, as you can see, are quite long, so you'll also have to scroll to see everything there. And we also have next to each of the block nodes, if you mouse over to the right, we'll have a little info box right here where you can see the same information. So if you have any questions about what a block node does, we've tried to build documentation directly into the tool for these. Cool. Let's see, did we have any questions in the chat I can answer here? Looks like everybody's on top of it. Would we want to do a quick little demo of tap to spawn particles or something? How are we doing on time? Do we have a lot of time? Or should like voice Q&A?
Yeah, I think we can do like 5 more minutes of demos, and then we'll wrap it up with the how to get started.
Cool. So I was just looking at the chat and I saw Bruno's question, is it possible to activate the VFX system after an event? And you could try that right now. We can see what that might look like. So like we said, we've exposed the spawn rate here, and then we've also brought it into visual scripting. So let's try creating a screen tap execution node. And then maybe we can also set a Boolean that we toggle back and forth. So let's try a set and an if. And so on screen tap, we're going to go into this if here, and then we're going to, let's see if it's true. Let's see, actually, I'm blanking on some of what I want to do here. Actually, let's not worry about toggling it back and forth. Maybe we can just start with the spawn rate set to 0. And then on screen tap, we're going to set the spawn rate to 3. That's going to be a lot easier. So let's give it a quick refresh to make sure. So now you'll see there are no particles spawning, and then we can tap, and now we have our particles. Tap, and yeah, so you could do it that way. You could expose the spawn rate and then set that in visual scripting. I'm trying to think if I have anything else I want to show off here. Somebody mentioned, can we change the shape of the particles? I think the easiest way to do that right now is going to be to go to this set main texture, and we could try using like bling texture, for example. In the future, we want to support arbitrary three. Oh, I forgot I have to tap. Let's see, that didn't make a huge difference, but maybe if we change it on the other ones as well. We just wanted to call out the easiest way to change the shape of the particles right now is going to be by changing the texture right here. But in the future, we are going to try and ship support for arbitrary 3D meshes as well. And we have a little more sparkly fireworks. Let's see. So mentioning not being able to see the event menu, let's see here. I believe that it is only accessible in the update context. So make sure you're trying to add the block to the update context. That's the only place where events are supported. And you'll notice that it's like that for a lot of the block nodes. They're only supported within a specific context. Like earlier, whenever I was trying to add gravity to the init context, but it wouldn't make very much sense there, so we've hidden it. Oh, post effects only to the particles. That's a really interesting question, Florencia. Post effects only on the particles. You can do that, This is going to be a pretty advanced topic, but you can do post effects only on the particles by selecting this in the hierarchy and then noting which camera that it's assigned to. And then if you change the render texture that VFX graph's camera is rendering into, you could create a new render texture, and we do have that, right? You can create a new render texture, and then you could make that camera render to your new render texture instead of the default finer render output. And then you could set up a post-processing effect that takes that render texture as an input, I believe.
Rustin, can you show the information on update and init for the world space?
Yes, so you'll notice that if I move around in the 3D view, this VFX graph, it's going to move all of the particles with it as I move this VFX graph around. That's not always what you want. So we also support a local space and a world space simulation mode that we can set in both the init and context. So if I change the simulation space from local space to world space, I think I'll have to do it on all of these to demonstrate what I'm trying to show. Let me also change the spawn rate back so I don't have to click each time. Whoops, I've zoomed in too far. You can see that now that I've changed the mortars to be world space instead of local space, they don't move whenever I move the system around. It's kind of hard to explain the use case for this, but if you need to move your particle system around, you want it to be attached to the user's head or something, it's super useful to be in control of local space versus world space simulation.
You can download the Visual Effects Editor beta for Mac and Windows on the blog post on our website. We do have a new channel in our Effect House forum, which is community.effecthouse.com, just for Visual Effects Editor. So you can go there to chat about the features, ask our team any questions, or ask other creators questions who have been using this tool. See you there. I'll be hanging out there all week. We do have a Ramadan challenge that is running March and then up into the beginning of April. So you can win cash prizes for making effects about Ramadan. So if you're interested, this is a great way to get started. And in fact, during the beta, we've actually launched some templates for Ramadan effects that you can create with visual effects. So if you open up the beta version of Effect House that you downloaded, you'll see those templates right on the home screen. If you're watching this after Ramadan challenge has ended, we're always running new effects and challenges. So check out the Activity Center on the homepage of the Effect House app. You'll be able to see all the different challenges and missions that are running for your region that you can enter right away.